When I tell people that my language of choice is Clojure, they often give me a certain kind of look. Not to say that I'm stupid or incompetent, but more like an absent-minded professor that wants to spend all day looking at flowers or thinking about type systems, rather than writing actual real production software. The purpose of this video is to dispel those rumors. Clojure is an absolute workhorse of a language for real people that want to ship to production and get things done. I personally use it for all of my own projects, and it's had success in use in production at real substantive companies. In this video, I'm going to tell you about why Clojure is so useful and how it's different from other niche languages like Haskell or Scala. If you've been an engineer for any amount of time, you're probably aware that when it comes to shipping useful software, the syntax and details of the language are often much less significant than the tools and the libraries you have access to. This is why even though Haskell is a phenomenal language, every time you use it, you have to ask yourself, do I want to re-implement NumPy? Do I want to re-implement sklearn? The defining feature of Java isn't its ability to define a struct in 13 lines of code. It's the other tools that are built around the language that make working with and refactoring Java code so much more palatable. Usually this is an area where small languages struggle to gain traction because a smaller ecosystem means less libraries being written. But it's an area where Clojure really shines. That's because Clojure is written on top of the JVM. And what this means in particular is when you're writing software in Clojure, you can import Java libraries and then use them just like you would any other bit of Clojure code. And what's really important here is this is a native integration. Unlike tools like Swig, this doesn't take any extra work to set up and configure. The syntax that you use to interface with it is the direct translation of Java code into Clojure's code structure. So if you know how to create an object in Java and call methods on it, then it's really obvious how to use it in Clojure. But Clojure goes one step further and even lets you import packages directly from Maven. This means that you can require Java packages and depend on them using Java's own native package manager. This means that it's really easy to import tools and libraries and everything just works. Like, because there's no manual setup or translation step or weird kind of indirection, that you can be confident that things are actually going to work the way you expect them to when you go to use it. But Clojure goes even one step further than other JVM-based languages like Scala or Kotlin. Thanks to the phenomenal library libpython_clj, you can actually call Python code directly from your Clojure project. So if you're in Clojure and you want to use NumPy, you can just import it and then use it just like you would the Python library. And what's more, and this is really impressive, is that the syntax that you use to interface with Python is so easy to manage. This looks like the direct translation of Python code into the Clojure style. And as a user experience, mentally, it just takes no extra work to do. Funnily enough, this kind of easy syntax is actually made possible by the paradigm of Lisp, because unlike languages like Java, Lisp makes it easy to write macros and modify the language syntax on the fly. So when you're doing these types of interop operations, you can actually define the language that you want, or the language that makes the most sense for interfacing with the Python code, and then you can add that new syntax into the Clojure language. The way that you get access to Python libraries is through pip, Python's own package management system. So if you want to use any Python library in your Clojure code, you can literally just pip install it and then require that library and use it directly in your code base. This is important because it gives you access to a ton of really important stuff. It's also an area where most other ecosystems expose at least one endpoint in Python. So if you think, I'll do it in Python, there's probably a library for it. And that means if you do it in Clojure, there's probably a library for it too. I just want to emphasize how easy it is to do this translation and to write code that relies on this interop. If you know any Clojure, you can read this code and it's obvious exactly what it's doing, even though under the hood it's actually interfacing with a library that's written in Python. This might not seem like a big deal to you if you've never had to do interop, but interop in other languages is messy. And putting it in a package that's this easy to use and works this seamlessly is really hard to get right. What's more, you can actually use Java and Python libraries together in the same program, and it works exactly the way that you would expect. I cannot stress enough how important this is. Usually the challenge of picking a programming language is that you're baking yourself into a particular ecosystem and into all of the tools and capabilities that exist within that ecosystem. But because Clojure can interoperate with everything else, you don't have to worry that you're pigeonholing yourself into a project where you'll write 10,000 lines of code before realizing that you're missing a library that you actually need. But we're not done cooking. You see, one of the really nice things about the design and implementation of Clojure is that most of the core libraries, the kind of key functions that make the language what it is and keep it running, are written in Clojure itself. Now, a lot of languages are designed this way, but Clojure has an especially small surface, which means it's easy to create implementations of Clojure that are different from the standard Java one. In particular, there's something called Clojure script, which allows you to take your Clojure code, compile it into JavaScript, and then run it anywhere that JavaScript can run. This is a huge deal because if you're writing a full stack web application, you can write the entire project, front end, back end, everything included, all in the same language. In particular, this also means that you can use tools like Capacitor to turn your project into something that can compile and run on phones, watches, and anything else people are putting JavaScript on these days. And I want to be clear, this is not WASM. This compiles directly to JavaScript using the Google Clojure compiler. So you get small bundle sizes and excellent performance. Because the Clojure scripts compiler means that your code is running directly on JavaScript, it also means that you can call JavaScript functions directly from your Clojure code, and it works exactly the way you expect. What's more, if you're using the Shadow CLJS compiler, you can import NPM modules directly from NPM, require them, and then use them as normal in your codebase. And I just want to emphasize how easy this is and how much it matters for doing web development quickly. The point is that it's so easy to get up and running with a new library that you don't need to spend an insane amount of time worrying about the interop from using a new language. If you want confetti on your website, you just import it and then use it, just like you would an NPM module in any other front-end JavaScript project. Taken as a whole, what this means is when you use Clojure, you have access to all of these other ecosystems. These are the 3 most popular languages. And so when you use Clojure, you get access to really the entire programming ecosystem. And you have all of the tools necessary to actually get the job done. Something I want to point out here is that even though other languages have facilities for interop, Clojure is unique in the way that it makes it easy and convenient to do. To give you an idea, I just want to show you the following React snippet and its translation into transpiled Kotlin. It takes a moment to visually parse. And more importantly, you have to have an understanding of what's going on and kind of how the interop works as a whole extra mental step to get to where you're going. In contrast, the equivalent Clojure code looks something like this. You can see exactly how it translates from the original JavaScript code, and you can just look at this and know exactly what it's doing. In some ways, the Clojure snippet is an even more concise way of phrasing what the JavaScript code is already trying to say. The Clojure script code doesn't just interface with JavaScript, it is a better JavaScript than JavaScript. And this continues to carry over, even as we get to significantly more complex code snippets. What's going on here fundamentally is that the syntax flexibility of Lisp makes it significantly easier to add new language integrations in a way that would be clunky or unwieldy in other environments. Importantly, and I cannot stress this enough, when you do interop in Clojure, you get to install libraries via every ecosystem's own native package management system. The difference that this makes is that you're not constantly trying to build pipes or cobble things together. When you want to use tools from other systems, they usually work correctly the first time. And so you don't have this tremendous burden of mental overhead. Next, I'd like to talk about another feature that makes Clojure development easy for me, the REPL. Basically, there are two categories of languages. Languages like Java and C++, which need to be compiled before they can be run, and interpreted languages like Python, which instead of compiling the entire program at the beginning, go through the file line by line and process and evaluate each statement of code. In particular, because interpreted languages can run without a compilation step, it means that you can open up an interpreter from the terminal and enter Python commands that you would like to be evaluated. What this means is that you can call functions, redefine things, and interact with your program without going through the step of recompiling it and running everything from scratch. Now, many languages have an interpreter, and many of the ones that don't allow you to attach a debugger, which does many of the same things. But what makes Clojure unique and special is the ease of use that it has for evaluating expressions and interacting with the REPL. To give you an idea, I'm just going to give you a quick example to show what it's like to work with Clojure code inside of your editor. In this example, I'll be using Cider plus Emacs, but there are similar plugins for most of the other popular editors like Vim and VS Code. So if I'm working on a Clojure program and I have an expression, I can put my cursor at the end of this expression, and then I can hit Control-X, Control-E to evaluate it and see the result. And what's cool is I can do this for even more complex expressions. So I can do things like define an if statement and evaluate it, define a variable, and then use that variable later on in my workflow. And I can also define functions and generally do anything else you would want to do in a Clojure program. Now, what makes this different than other programs like a Jupyter Notebook is that you're doing all of this inside of your main source code files. So if you just want a little scratchpad, you can open up a new empty file and mess around with it. But if you want to, you can actually open up your main program's logic and then execute bits and pieces of it inside of your main program's source code. And this is really, really useful for actually working on a program or building up a change list. So when you're writing new software, it's really easy to make changes and to test out those changes. But then when you're done, since you're working inside of the main source code, you actually get something that looks like a real program or that looks like a real change list. And so it's really easy to go from playing around with stuff to a pull request that's ready for review. If I want to try something out in one of my main files to see how it works, I can actually just go and test it directly where it's defined in the source code. And so even just mentally for documentation, it makes it so much easier to understand how to try stuff than it would if I had to open up a new terminal window, import this namespace, and then copy paste this command into the interpreter prompt. Now, many languages have this or something like this. So there's a Python mode for Emacs that lets you evaluate statements in line inside of your editor. But what makes Clojure so special is because it's a Lisp language and you can view your entire program easily as a syntax tree, it's much easier to navigate in and around your program with your cursor and evaluate bits and pieces of it. To show you an example, let's look at the following code snippet in Lisp. If I want to evaluate just the addition clause, I can put my cursor at the end of this expression and hit Control X, Control E to execute it. If I want to evaluate the entire Boolean condition, I can put my cursor at the end of the line after both parentheses and evaluate it. And if I want to evaluate this entire if clause, I can put my cursor at the end of the entire expression and evaluate this whole expression. Now, if I wanted to go ahead and try doing the same thing in the Pythonic style, if you want to evaluate individual bits and pieces of this program, you cannot easily put your cursor in a position and define which part of the program you want to execute. This is because the syntax of Python isn't organized into parentheses blocks that all evaluate to a value. In this example, the code relies on an implicit order of operations and the parsing and syntax of the language rather than an explicit structure. And so there's no way to easily untangle it when you're trying to evaluate bits and pieces of code. Additionally, most common statements in Python don't evaluate to a value. This snippet of code does something, but it doesn't return anything. So if I go ahead and I evaluate this block, it isn't meaningful to me. I'm not going to get a return value that I can see and interact with. Deep down, even though Python has the ability to interact directly in your editor, the reason why a tool like Jupyter is necessary is because you need to define special blocks in your program in order to specify which groupings of code need to be evaluated and to display something that looks like meaningful output. Because navigating around Clojure code is so nimble, you don't need to add this extra level of obfuscation in order to play with it interactively. And so when you're working with Clojure source code in the same style and the same feeling that you would want to interact with a Jupyter notebook, you get something that looks like real source code and not something that looks like a tangled mess. And so now I'd like to zoom in and talk about some of the more specific features of the language itself. As you probably know, an object is immutable if it cannot be modified after it is created. In Clojure, you can use mutable or imperative programming if you really want to, but most objects are immutable by default, and you can only get a modifiable object if you explicitly declare it as such. It's kind of like the difference between being able to pass by value and pass by reference. But unlike languages like C and C++, because of the way Clojure's default data structures use data sharing and some clever tree manipulations, you can manipulate these immutable data structures, and you can return a new updated copy without actually copying the entire array. You also don't get goofy, scary errors when you try to do stuff. To show an example, let's take a look at the following snippet of Python code. Even though numbers and strings are considered value types and are immutable by default, Python lists are not. And you can see here, we're modifying the array's contents, the stuff that's actually inside of the array, without reassigning the variable x. So this snippet of code assigns a value to a variable name. And this snippet of code modifies an object that already exists. To show what I mean, in Clojure, if I create an array and I modify one of its elements, this creates an immutable copy of the original array. So the value that's actually inside of the variable x remains unchanged. To show you that these are really two different copies of the original array, I can even do something like assign this to a variable y, and then show you the output of both x and y. And what's very cool about this is you can actually do this very efficiently through the use of data sharing. So you can actually run this code and have two immutable copies lying around without taking an O of n performance hit. It's pretty cool how this works, and I have an explanation of it in one of my other videos, but it's more than a 30-second explanation. So if you're interested, I'll link that in the description down below. This also works with hash maps. So Z is unchanged after this operation. And because Clojure's object types are really just Clojure maps under the hood, this works with Clojure's objects and stuff as well. What this means in practice is that most things are immutable everywhere in your code. Again, you have the ability to create mutable references if you really want to. But because most of the things that you work with are immutable most of the time, and because you know explicitly when something is not immutable, it means that all of the different pieces of your code are untangled from each other. And it means that if you call some function on a list, you don't have to worry that it's going to destroy an instance of that list that's being used by some other code somewhere else. Because you know that this list is immutable, it's not up to the user of this list to understand which functions do or do not modify its value. This entire list is immutable, so every operation you do on it is not going to have side effects on it. And you know that, and you don't have to worry. What's more, and what sets this apart from things like immutable list in Java, is that these things are actually efficient to work with, so you can actually use them everywhere in your code without worrying too much about the performance hit. And they are the default data structure. So everything else uses them and returns these things. Overall, you get an environment where there's just much less to think about. And because there are fewer state changes, it makes the different pieces of your code much easier to isolate and test. One of the more interesting design choices in Clojure is that almost all data structures and objects that you encounter use either lists or hash maps by default. To see it in action, and as a point of contrast, let's take a look at the following class definition in Java. It defines a few internal variables, a constructor, and getters and setters to update and access the information inside of the class. Now, proponents of Java would tell you that this gives you better encapsulation and isolation. But the problem is that all of the getter and setters and updater functions are sort of unique and a la carte to this class. And as a result, it becomes much more difficult to define and implement higher order operations, such as merging maps together or walking through the values in a tree of nested maps. So now let's take a look at the much shorter definition of a circle class in Clojure. I can create an instance of it, just like you would expect. But what's really neat here is because this carries the same structure as a hash map, I can do map operations on this data structure. So I can do things like deep update one of the fields, create a simpler object from an existing one by selecting a subset of its keys, or even just using the keys function to see what fields are accessible inside of an object. And what's interesting here, and this is the point that I really want to make, is you can see a list of fields inside of a Java object by using reflection. But because objects are their own thing and their own world and their own data structure, you probably don't remember what that function is or how to use it. Whereas in Clojure, because the same functions work everywhere on everything, you get really familiar with these functions, and it's much easier to guess what you need and what you're supposed to use. Another sort of subtle benefit is that it's much easier to see sort of a diagnostic printout of what your object is and what's inside of it. This is just a simple map, so that sort of transfers anywhere. And so when you're working on projects, it's much easier to see your intermediate output and create dummy values of it when you're writing tests. I actually have some gripes with Clojure's object system, but I'm able to fix them myself, thanks to the defining feature of Lisp languages: macros. Macros let you redefine the syntax of the language from within the language itself. For those of you not familiar, it feels a little bit like playing Calvin Ball, in that you can turn the language into whatever you want it to be. It's one of these features that's possible because it takes advantage of the unique syntax tree structure of Lisp, in order to make it easy to define transformations that operate on that syntax tree. I made a full-length video explaining what this is and how it works. So feel free to check that out if you're interested in learning about this stuff in more detail. But I'll give you the TLDR here as well. If I'm anywhere inside of my Clojure program, I can define a macro, which is a little transformation that takes code as input and produces code as output. Then whenever I use this operation, It transforms this bit of code at read time before anything is actually evaluated. And then it executes the new transformed code in place of the original. Because this happens at read time, you can do things like operate on symbols or conditionally execute code without wrapping everything in a Lambda expression. Importantly, you can define these syntax transformations inside of your main source code rather than needing to write your own separate compiler. In particular, what this means is you can add special syntax that's particular to a specific task or project. And you can even import syntax as part of a library that you want to use. Going back to what we discussed earlier, it's this feature that makes interop and Clojure so palatable. Because when we use the library for interop with Python, we can also import the syntax for interacting with the Python language. Macros are one of these features that I use very infrequently, but when I need to write one, it's extremely valuable. This is because whenever I use Clojure, I know that I'm not going to get stuck with something that I don't like and can never change. I don't like certain aspects of the object and class system within Clojure, and so I'm writing my own modifications to it, and I love that I can just do that without breaking compatibility with existing tooling or other libraries. I'm actually planning to make my next video on how I built this custom object system and how it works, and also why I built it. So if you're interested in that, make sure to subscribe and follow the channel. I know it's one of these things that's annoying to ask for, but I tend to find that with the YouTube algorithm, you tell it your preferences and then it just ignores you and does whatever it wants. And so as a channel creator, it helps a lot when you follow stuff if you want to see it. Overall, I think a lot of people see Clojure as a niche or elegant language, but it is the language's pragmatism and ease of use in practical applications that truly makes it a joy to use. Deep down, Clojure is just Lisp for the JVM, but it's the unique design of Lisp that lets you build all of these tools and features that operate around the language. Really, I cannot stress enough how valuable it is to have macros available in your language. It's the key ingredient that allows your ecosystem to thrive and grow, even as the core language itself remains extremely, extremely stable. So if you're interested in picking it up, there's a bunch of tutorials here on this channel, and everyone in the Clojure community on the forums and stuff like that is super welcoming and friendly and helpful. So yeah, if you enjoyed the video, give it a like, subscribe to the channel, and I'll see you in the next one. Writing our own object system, it's going to be a good time.